Hello everyone, this is a report for Team 25. Our team members are Linling Guo, Amit Pariwal, Jaewoo Park, Xuexian Qin, and Edik Simonia. Our project is to build a client-side application that can triage a patient and can track the progress of that patient. The application must take the triage results and assign the patient a severity level. The higher severity patients will have higher priority to be seen by physicians and nurses. For the patients that have same severity, it will be a first in, first out. The main users of our applications are RNs or other hospital staff at the emergency department. We have two use cases. The first one is for checkup for new patient that enters into the hospital, and use case 2 is for fetching patient progress report. The left side of the slide is our prototype diagram. The two use cases are separated by 1 point and 2 points. We have 6 steps for use case 1 and 3 steps for use case 2. The rectangle are components and the ellipse are our database. The components will communicate through REST and the WebSockets. Our data structure is queue-based. Patient information will be sorted in either one priority queue or different queues for different severity levels. We have 2 separate databases, patient data and hospital staff data. These 2 databases will be used to track available hospital staff to attend to patients and to track patients' progress after admission. Now let's see the details for use case 1. The patient information will be entered through the triage front end, and then the information will go through our ranking algorithm at the back end. The ranking algorithm will then prioritize the patient and add the patient to corresponding severity bucket. Patient information will then be added into the queue through the producer. The consumer components will receive the patient information and match the patient to available staff and the doctor based on the severity level. Once the patient is allocated to a doctor or staff, the patient information will be added to patient database. Now let's see the details for use case 2, fetching patient's progress. The hospital staff operating using our triage application will request for patient's progress. This request will be handled by patient's progress component. The patient's progress component fetch patient's information from patient's database, and then the patient progress components will return the information back to the front end.
I'll take over and finish the rest of the presentation. So my name is Linling. So I'm going to introduce the technology and languages that we may use for this Team Sprint 3 project. On the client side, Reactive, TypeScript, and Webpack can be used. On the server side, Python, FastAPI, or Flask, or OpenAPI are possible choices. The database, there are a bunch of choices, including MongoDB, Elasticsearch, depends on whether we want to do search, and RabbitMQ. For the continuous integration, John Docker compose of development, and Helm charts, if applicable, will be used. So this is the deployment pipeline. When a committer merges changes to release branch to GitHub, John will pick up the changes to the release branch via webhooks. This can register and update the Docker image to our centralized image repo. John will make sure the build will pass all the requirements. This is a CF test. After that, we'll deploy with K8s to HDAP. and application request will be made through Nginx or UVicore. The other very important component of this project is mockups. So this slide shows the login mockup. So on the top left, the top, there is a URL for the login for the emergency department triage and resource management system. So it requires a username and password to sign in. So this slide shows resource management mockup for the mockups. So when the patient is called in, the patient will be assigned a bed, for example, whether it's bed 1 or bed 5. Afterward, it will be assigned to a nurse, depending on the nurse schedule too. And then will be sent to a doctor. The important thing is we have to decide on the patient severity, emergency level. There are resuscitation, emergency, urgency, urgent, semi-urgent, non-urgent situations, so that we decide how to call in the patient. So I will explain in more detail in the next few slides. On the right hand, it's just showing, it's like a patient ID card, showing the unique identifier IDs, like the insurance ID, for example, and also the name of the patient, the date of birth, age, gender, whether it is allergic to some medication, and then also the past medical conditions or history. As I mentioned before, so this slide is a dashboard mockup that is characterizing how we define the severity levels of the patient for their emergency situations. We have different levels that we quantify them from level 0 to 1 to 2 to 3 to 5. For level 1, when the patient needs resuscitation, the average wait time, for example, is 5.3 seconds. The next level 1 is an emergency situation. Average wait time is 29.3. For level 2, it's an urgent situation. Average wait time 25.18 seconds. Semi-urgent situation, wait time even longer. And for the non-urgent situation, and it's over 1 minute, 25 seconds. So that when the patient call in, for example, with the patient 001, if it's a very emergency situation, will be calling right away, versus whether the least urgent situation for patient 014, it will call in last. So we will assign them to the different bed, then to our available personnel that includes nurse or doctors, and also we'll have a record of how busy this personnel. For the UI mockups, as presented here, when the patient arrived, they will be handed a questionnaire asking about their medical history, kind of situation, and so on. So the patient, if they are in an emergency condition, they will call it immediately. If less emergent, we'll add them to the wait queue. This is the showing for the triage form mockup. On the right side is the patient ID card, which I have shown before already. For the UI, we have done more research to look at how to assign patients to different severity levels, what parameter to use for ranking algorithms, and or existing efficiency triage system instruments, and so on. I won't have enough time to cover, but you guys are welcome to look at those papers. We have done more research. So for this Gantt chart, we have successfully finished everything for last project and also this project, and we have a lot of work to do for the near future. Project 2 will keep it updated.